Leetcode problem 261 graph validated tree. So we are giving a graph structure. We are going to check if this graph can become a tree, but it should be validated tree. Let me explain this problem. We should know about what should be a graph. So for example, this node connected to this node. There's another two nodes. They are also connected. This is a graph. And this is a validated graph, but it is not a validated tree, because if it is a tree, all the nodes should be connected like this one. But as you can see, these areas, those two nodes connected, the above two nodes also connected, but the whole part is not connected. So this is some cases. There's also other cases. For example, we have three nodes, and they are connected with each other. So is this a validated tree? It is a graph, but it is not a validated tree. So this is another case, So if there is a structure like this, so this is a validated tree, So according to three different cases, how should we solve the problem? I think we can use unified to solve it easily, and we just need to check the connected edges. For example, we're gonna check these two edges. If they are not connected, we're gonna connect them. If those two edges, if they are not connected, we're gonna connect them. And then we're gonna check those two edges. If they are already connected, so we're gonna return a false. Otherwise, we're gonna return true. Otherwise, we're gonna return true. So this is for the situation if the graph is not like this. We have to check this one. If the graph is not like this, we're gonna check in the second case. And then the third case. But how can we check the first case? We just need to check how many nodes and how many edges. So for this graph, there are 4 nodes and 2 edges. Definitely, it is wrong. So what we need to do, we need to have like 4 nodes with 3 edges. If there are 4 nodes and 3 edges, we're gonna check the second case and the third case. But if there are 4 nodes with 2 edges, definitely we're gonna return a false. Now let's get started coding. As I said, I'm gonna use unified. So we should try to write a basic unified structure. So the unified can be really complicated, but for us, I think in the interview we need to write at least a very basic structure of unified. So basically we're gonna write initialization. I'm gonna write a path first. We're gonna write some API like find and union. Definitely we're gonna need the find and union. I will use a path at the moment, and then I think I need a union. So self.n1 and n2 union of the 2 nodes. And for me, I also need is connected check. I need to check if those 2 nodes are connected. So basically, this is my API for the unified. We need to basically we need to write it for ourselves. We don't need to copy it every time. So this is the unified. So if I have the unified, what I gonna do? As I said before, I use the unified. I need a check, validation check. So if this n are not equal to the length of edges plus 1. Normally, if this n equal to the edges plus 1, I'm gonna check the second case and third case as I explained earlier. But if it is not equal, so I'm gonna return a false immediately. So this is just like this case. So for example, those 2 nodes connected, those 2 nodes connected. So the above 2 nodes connected, below 2 nodes connected, above 2 nodes connected. So how many nodes? 4. How many edges? 2. So if it is like this, if they are not equal, 2 plus 1 not equal to 4, I can return false immediately, because definitely this is not a validated graph, validated tree. I needed to check the validated tree. Now I will go to the second step. The second step and the third step, I'm gonna use the unified. So the UF should be equal to UF. I will give a value n. This is the number of nodes. Now I will check all the edges. So for UV in edges, So if it's connected UV, so if they are connected, so I can return a false immediately. So this means while I'm checking those two nodes U and V, if they are already connected, I can return false. If they are not connected, I will union them together. I will connect them together, so I can use UF dot union with U and V. Yeah. Finally, if I didn't return a true, return a false, I can return a true safely for the final result. Yeah. Now I just need to finish writing the unified. So for this problem, I just need to write a very basic unified. I don't need to use a path compression. I don't need to use a racking. I just need to write a very basic unified structure. So I can use array as the unified because their number of the nodes is just 2000. Yeah. So it's gonna be, I will use a list range with n for the initialization of the parent array. Now I can write find and is connected. I think is connected is easier to write. We just need to return self.find n1 equal to self.find n2. Yeah, and union is also really easy to write. Let's just write the union. We're gonna prepare p1 p2 should be equal to self.find n1 and self.find n2. Then we're gonna put them together. So I will prepare the parent of P1 should be equal to P2. Yeah, so the parent of P1 should equal to P2. Or you can make it P2 equal to P1. It's the same for the algorithm. Yeah. So P1's parent is P2. Now we finished the union. Yeah, let's finish the difficult part. It is find. Basically, there will be more line. Basically, if this n not equal to self.parent, if not equal to its parent, what are we gonna do? Yeah, we're gonna update the self.parent array. It will be updated to self.parent array. Inside it should be self.parent with n. Yeah. So I will not explain what is why it works for the unified. You can check my other videos. I have a detailed explanation of why we're gonna do it like this. Basically, the unified is to connect the component in a graph. If they are connected, we're gonna use the unified to connect them together. And after connecting all the connected components, we can check it easier because we can just use similar to O1 time. For my time complexity, the unified is log n. It is not O1 because I didn't use the racking and path compression. Yeah, but basically, if we are going to use the template, basically we're gonna use the optimized unified. Yeah, but this also works if you want to write for yourself. Yeah, you can write it like this: self dot yeah, and after that, n should equal to and self dot yeah, after that the self dot parent n yeah, n should equal to this self dot parent n should equal to its parent, and finally we just need to return this node n. Yeah, so this is the file. If we didn't, yeah, if its parent is not itself, it means we need to still to find its parent. If it is equal to itself, it means there's no connected component. If it is not equal, we're gonna search it. Yeah, we're gonna find its parent until we find it, and then we define this n equal to yeah, its parent. We just need to return this n. Actually, this n is its parent. Yeah. Now let me run the code to check if it works. It's connected, not defined. Oh, is connected. Here should be uf dot is connected. Yeah, now as you can see, it works. Yeah, hopefully I didn't make a mistake. Now let me submit it to check if it can pass all the testing cases. as you can see, it passed all the testing cases, and the time complexity is n log n because we used the unified. I didn't optimize the unified, it is a log n, so it is 2000 times log 2000. So for the edges it is 2000, and for this unified check it is log n, so it is n log n time. Thank you for watching, see you next time.